Hello friends and my dear students, welcome back to my channel Phoenix Physics. Today we are going to discuss resistors in series and resistors in parallel. Before going into this topic, just to recall Ohm's law, that is V is equal to IR. Current through the conductor depends upon its resistance and potential difference across its end. This is Ohm's law. In various electrical circuit, we often use resistors in various combination. There are two methods of joining these resistors. One is resistors in series, another one is resistors in parallel. For each type of circuit, we can calculate equivalent resistance produced by group of individual resistors. How do you construct resistors in series? When two or more resistors are connected end to end, they are said to be in series connection. It could be simple resistors or bulb or heating element. Look at the diagram. Here R1, R2, R3 resistors are connected in series. The amount of charge passing through R1 must pass through R2 and R3. Since there is only one path for the charges to flow through, the current is same through all the three resistors. Here I is same. According to Ohm's law, if same current flows through different values of different resistors, then the potential difference across resistors must be different. For example, here R1 is 1 kilo ohm, here R2 is 2 kilo ohm, here R3 is 3 kilo ohm. If the same current flows through different values of different resistors, then the potential difference developed across these three resistors will be different. Let V1, V2, V3 be the potential difference across R1, R2 and R3. You can write V1 is equal to I into R1 because I is same. Then V2 is equal to I into R2. V3 is equal to I into R3. So the total potential difference is equal to the sum of potential difference across each resistor. That is V1 plus V2 plus V3 is equal to capital V. What is V1? IR1. Substitute the value. IR1 plus IR2 plus IR3. I is same, so take it outside. I into R1 plus R2 plus R3. This is equal to potential difference, total potential difference V. Then you can write it as I. Instead of R1 plus R2, R3, you can write RS. What is this RS? RS is nothing but equivalent resistance. So RS can be written as R1 plus R2 plus R3. Then what is your conclusion? Equivalent resistance is equal to the sum of individual resistance. Here the value of equivalent resistance will be greater than the value of individual resistance. What is the meaning? See, here R1 is 1 kilo ohm, R2 is 2 kilo ohm, R3 is 3 kilo ohm. You know the formula, that is R is equal to R1 plus R2 plus R3. So R1 is 1 kilo ohm, R2 is 2 kilo ohm and R3 is 3. Totally you can get 6 kilo ohm resistance. This is your equivalent resistance. The value of equivalent resistance is greater than the individual value of resistance. So RS is greater than R1, greater than R2, then greater than R3. This is the meaning. What is your conclusion? I is same, V is different, Then third point, equivalent resistance. The value of equivalent resistance will be greater than individual resistance. You can verify these 3 points with this experiment also. Here R1, R2, R3 resistors are connected in series with battery, ammeter, and this one is plug key. Just remove the plug key. You can see the ammeter reading. From this ammeter you can easily measure current value. Now you shift the ammeter position from here to here. You can get same reading only. From this experiment you can conclude that current is same in series connection. Then how do you verify? The second statement V is different. One voltmeter, connect across these 3 resistors. Now you can get one value. Mark the value. Say this value is 6 volt. Then you remove the voltmeter. Now you connect voltmeter across R1 resistor. You can get one value. Say this one is my V1. Then again you remove the voltmeter, connect across this resistor. You can get the value V2. Same way you can get the value V3. Now add V1, V2, V3 value. You can get total voltage across the 3 resistors. From this experiment we can verify these 3 statements also. Next topic is resistors in parallel. When 2 or more resistors are connected across same potential difference, they are said to be in parallel connection. Look at the diagram. Here V is same for all the 3 resistors. Why? Because this will create one circuit and this will create another circuit. Here the total current is split into 3 parts: I1, I2, I3. So I1, I2, I3 be the current through R1, R2 and R3. Total current I is equal to I1 plus I2 plus I3. This is our equation 1. From Ohm's law, V is equal to IR. Suppose I want I means you can write V by R. Current through the resistor R1 is equal to I1, that is V by R1. Current through the resistor R2 is equal to I2, that is V by R2. Current through the resistor R3 is I3, that is V by R3. Substitute in equation 1. That is I is equal to V by R1 plus V by R2 plus V by R3. Here V is same, take it outside. V into 1 by R1 plus 1 by R2 plus 1 by R3. This is our I. So how do you write this equation? I is equal to V into 1 by Rp. What is this Rp? Rp is nothing but equivalent resistance. This Rp is nothing but equivalent resistance. How do you get this Rp? Just to combine these 3 resistors, you can get equivalent resistance Rp. So Rp can be written as, that is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. The equivalent resistance of the parallel connection is equal to the sum of reciprocal of individual resistance. Then what about this Rp value? Equivalent resistance Rp will be lesser than the individual resistance. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. For example, you take it as R1 is 1 ohm, R2 2 ohm and R3 3 ohm. Then how do you write? 1 by 1 plus 1 by 2 plus 1 by 3. Values 1 plus 0.5 plus 0.33. You can get 1.83. This is 1 by Rp. Suppose Rp means we can get 0.5. That is why we said RP will be lesser than individual resistance. You can easily conclude 3 points. First one, I is different. Second one, V is same. Then third point, RP will be lesser than individual resistance. These three are very, very important ones. What is the practical applications of series and parallel connection? In series connection, when one component fails, the circuit is broken and none of the equipment works. But in parallel connection, each gadget require different amount of current to work. So most of the home appliances are connected in parallel connection only. In this class we discussed about resistors in series connection. We derived the formula R is equal to R1 plus R2 plus R3. What is this R is? Equivalent resistance. From this formula we concluded 3 points. If it is series connection, the current I is same, potential difference V is different. Another important point, the value of equivalent resistance in a series connection will be greater than the individual resistance. Next we derived the formula for resistors in parallel connection, that is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Again from this formula we concluded 3 points. If it is parallel connection, current is different but potential difference is same. Another important point is the value of equivalent resistance in a parallel connection will be lesser than the individual resistance. I hope this video is useful to you. If you like my video, please share and subscribe my video. Thank you.